Welcome back. Today I'm going to teach you a shortcut to prove triangles are congruent. In the previous lesson, we learned that in order to prove triangles are congruent, you must show that 3 pairs of angles are congruent and 3 pairs of sides are congruent. However, today I'm going to show you a shortcut called side, 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 and another called side, angle, side. The first, side, side, side postulate states that if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the 2 triangles are congruent. So for example, if you know that AC is congruent to DF, CB is congruent to FE, and BA is congruent to ED, you have 3 pairs of congruent sides here, you can automatically conclude that the triangles are congruent. So we could say triangle ABC must be congruent to triangle. Now let's see, make sure we name this in order. A is between the sides that have 1 dash and 3 dashes. D is also between the side that has 1 dash and 3 dashes. So I'll need to make sure that I pair up the corresponding parts. A must correspond to D. After that, I can just go in a circle. For ABC, I would follow it in order. So from A to B and then to C, I must go in the same order for D, the other triangle. So I did the side with 1 dash first. So I'll do D to E first. And then going back around my triangle, I'll go to F next. Alright, so basically today, instead of showing that all 3 pairs of sides and all 3 pairs of angles are congruent, you can cut it short and only show 3 pairs of congruent sides to save time. And this theorem, this postulate, says that you will still know the triangles are congruent based on the fact that 3 sides are congruent. Alright, let's try this in a proof. I already labeled a little bit for you here in the picture in the diagram. Go ahead and do the same on your paper. We're trying to prove that the triangles GHL, this triangle here, and KJL, this triangle here, are congruent. So remember, we always start with the given, so we'll just rewrite that first. Now, in order to show that these 2 triangles are congruent, I need to show that the last pair of sides, GL and LK, are congruent. So, I know that there's a third angles theorem, but that does not work for sides. It only works for angles. However, I do know that L is the midpoint of segment GK. Remember, midpoint means that it's the point exactly halfway between the endpoints. Midpoint theorem tells me that these 2 segments would have to be congruent. So then I would have all 3 pairs of sides congruent. So by midpoint theorem, I need to say that those 2 segments are congruent. Just make sure you list these in corresponding order. So if I say GL, that's the first letter and the last letter, I want to make sure that I go in order. So K corresponds to G, L corresponds to itself L. Just so you know, a point does not always have to correspond to itself. That's just in this case. Finally, my last step, now that I have all three pairs of sides congruent, I can say these triangles are congruent by the side, side, side congruence postulate. Alright, next I'm going to talk about side angle side postulate. It can be abbreviated SAS. Highlight this, it's super important. It says that if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the two triangles are congruent. Just so you know, the included angle, that basically means it's the angle formed by those two sides that we're talking about. So, if we are given that AB is congruent to DE, BC is congruent to EF, and angle B is congruent to angle E, we can conclude that these two triangles, triangle ABC and triangle DEF, must be congruent. This is by the side angle side postulate. So I no longer even have to have three pairs of congruent sides. Now I only need two pairs of congruent sides and the angle between those sides. So it's another shortcut to show that triangles are congruent. Let's do an example together. It says the scaffolding for stage lighting shown appears to be made up of congruent triangles. If WX is congruent to YZ and segment WX is parallel to segment ZY, write a two-column proof to show that triangle WXZ is congruent to triangle YZX. Alright, so we already have some of the proof filled in. I redrew this just because it's a lot easier to see without all that extra stuff in the way. Now I want to label what I'm given. I know segment WX is congruent to segment YZ. I also know that these two lines, WX and ZY, are parallel lines. I'm trying to prove that triangle WXZ is congruent to triangle YZX. I always start with the given. How can I tell that segment XZ is congruent to segment XZ? Do you know this answer? Again, if it helps, you may want to draw this out as two separate triangles. So I have WXZ and XZY. So I just showed that XZ is congruent to XZ. It's always helpful when the two triangles are touching because you automatically have one pair of sides congruent, since a segment is always congruent to itself. Next, it says to use alternate interior angles postulate. So if I'm looking at this, I'm going to try to decide which transversal do I want to look at. This transversal, if I'm looking at alternate interior angles, it would either be this angle and this angle, or this angle and this angle. Either way, both of those angles are not in the triangle. So let's look at a different transversal. How about this one? The alternate interior angles would either be here and here, or here and here. Notice with this example, the angle goes outside of the triangle. So I want to stick with these. Let's look at it on our other diagram as well. Notice that the angle falls between the two sides that we already have congruent. that means that it's the included angle. That's perfect. Let's say that these two pairs of angles are congruent by alternate interior angles postulate. So it would be angle WXZ must be congruent to angle YZX. You'll want to go in order based on what is corresponding. Finally, we can say the triangles are congruent by the side angle side congruence postulate. The last part of the lesson today is to reflect on this question, please. Determine whether the following statement is true or false. If it's true, please explain your reasoning. If it's false, please provide a counterexample. That's all for today.